Today I'm going to introduce you one of our equipment for preparation of cryo samples, Leica Great Plunger, Leica GP. So if you come to this room, first thing what you have to do is sign in into the logbook. And please be careful because this room is temperature and humidity controlled. So always keep the door closed. In the summer months it can happen that the humidity is a bit higher than it should be. Therefore, you can see a bit more ice contamination than in the winter months, so please be careful about this. To start the grid plunger, there is a main switch in the back of the machine that you just press, and you can see that the screen has lit and it starts to work. Now it's making the initialization. It takes some time. And then there is a message saying that to start the initialization, you should touch the screen. So you have to wait a bit. It takes some time, as I said. So I start the preparation by just touching the screen, and there is the message that the great plunger is initializing, and you can see that the chamber is rising up. Now you can see that the great plunger is on, and there are a few messages which are shown in the upper left corner in yellow square. Now it says you to exchange the filter paper. To exchange the filter paper, you have to open the door of the chamber. Please never touch the filter paper with your hands. Always use gloves or tweezers not to contaminate it. And you can see there is a metal plate. So you put the filter paper in and you use the metal plate to secure it. On the metal plate there are numbers, because every filter paper can be used for up to 10 plunges. So the numbers are just control for you, that you know that, okay, I'm at number 10, I have to exchange the filter paper again. After you exchange the filter paper, you can press to this yellow message saying, I have done it. And now there is another one, which is saying humidifier empty. First fill 60 milliliters of distilled water and refill 20 milliliters. So distilled water you can find in here. And here is a syringe for 60 milliliters exactly. So if you put the 60 milliliters to the syringe, and now the humidifier has this hose going in with the valve, so you have to open the valve, plug the syringe in, and you can press slowly, and this is how the water is being refilled. So after you fill the 60 milliliters, you can close the valve, and you see the message disappeared, and it changed that the liquid nitrogen is empty to fill the liquid nitrogen. While working with liquid nitrogen, it's really important to use the protection, meaning use the glasses and goggles all the time, just to keep you safe. So there is this beaker, and there is a liquid nitrogen prepared. So you can carefully refill the liquid nitrogen to the beaker. Be careful, since the beaker was warm, so it's still cooling down, so it's kind of boiling, so you have to wait a bit until it's full. And now I can refill the rest. So I can really slowly start to fill the liquid nitrogen into the GP. Again, be careful because the GP is now completely warm. It's on room temperature, and you see that it's bubbling, it's boiling in there because the liquid nitrogen is cooling down. So, for example, now it will tell you that it's already full, but it's just that the sensor is confused because of the boiling. So please start refilling slowly, and it's better that it takes some time. Here you can see a value of the liquid nitrogen. So far we are on 25%, and you can see that the temperature goes slowly down while we are refilling it. You reach the value of liquid nitrogen of 50%. The message on the yellow upper corner disappears, saying that it's already being cooled down and there are some liquid nitrogen value already inside. You can see that now the temperature is already on minus 179 degrees of Celsius. So now it's time to put inside two things. One is the container for the grid boxes. So you can see I put it, there is this hole and there is a pin, so the pin has to fit into the hole. So you can see now we cannot easily move or rotate with this container. Unfortunately, you have to be careful because if you put something in which is warm, the value will go up again slowly. Another important part of this machine is the container for liquid ethane. The container for the liquid ethane goes in here. Please be careful to put it there afterwards, not to contaminate it with the liquid nitrogen. So now the temperature rises a bit, so we have to wait again after it reaches the value below 180 degrees of Celsius. You can set the temperature what you want to reach in here. If you press to this blue square, there are set temperatures what you want to have. This is the chamber temperature where your sample will be. Now it's on 12 degrees, it's slowly cooling down to 4 degrees. The relative humidity of the chamber is set to 75%, and the liquid ethane container temperature is set to minus 184 degrees of Celsius. If you want to change some value, you just click on this value and you can see there are some preset values what you can set. For example, cryogen temperature is from minus 196 to just 100. I would leave it. Usually we are working with temperatures of minus 183 to minus 185, basically depending on your speed and so on. So I think 184 is perfect, so we can leave it. Since we are not working with sensitive samples, we can work with like 16 degrees. If you change it, press OK, and you can see that this value now changed in here. So the chamber temperature will aim for 16 degrees. The same with the relative humidity. So if you are happy with the settings, you can put in there the hose for liquid ethane. Again, it has to cool down, so it takes some time. Liquid ethane you can find in here, and here it's really crucial to really wear your gloves and glasses. Please be careful. If you spill on you the liquid nitrogen, it could be fine. If liquid ethane, you will be really burned. So be careful about it. Firstly, you can flush the ethane hose, just opening quickly and closing to make sure there is no dirt in the pipe itself. So there are two valves. One is in here, the smaller one. Second one is in here. So be sure you are always opening and closing both of them. So then the liquid ethane goes on the liquid container, and you just have to leave this metal thing to cool down. You can see it on the screen that it's really the temperature of the ethane container is rising quite heavily, so it takes some time to cool down. So let's go through all of the other settings of the GP. Here is the light. It's always convenient to work with the light on. Of course, it's much better. The count is, as mentioned before, it's the count of the filter paper. It's automatically in the beginning set to 10 because I said, if you remember, that I put there the new filter paper. If you want to restart the count, you just can press and it will ask you if you really want to reset the filter paper counter to 10. Yes, the same with light on. Now it's off, now it's on. I have shown this. This is the values of the chamber where your sample is. Then there are a few programs. If you want to if you press here, you go to the program settings. There are the GP can remember up to 10 programs, and you can rewrite all of them just by pressing on the number. This is how you choose the program. First is the first rotation. The first rotation means that it's the rotation if you load your sample and you put it to tweezers, and it's the rotation before the sample goes up to the chamber. Setting rotation is the rotation after you are in chamber, meaning if you are right-handed, you pipette your sample to the grid, and then you want to have front-side blotting. I will show you later. It's always good to have it on. Sensor, it means that there is a sensor which detects if the blotting was successful, and basically after the sensor realizes yes, sample is being blotted, then the count of your time will start. Auto plunge is recommended to have always on. It's the automatic plunging of the sample. It will just save you time. Pre-blotting and post-blotting times are incubation times basically of your sample. And blotting time is the time for how long the sample is touching the filter paper. If you want to change some settings with first 4 values, it's okay just to press to uncheck or check. With last 3, it's the same as before. If you press, now you can set it to whatever is sufficient for you. Usually we are using blotting times in between 1 and 4 seconds for the starting experiment. As I said, of course, depending on what you are doing. If you are happy, you press OK. Another settings you can find under the setup. And here are the blotter settings. Please be careful if you are changing something, the chamber is going down. Just to make sure that there is, for example, now there is this ethane valve plugged in or put in, so it would squeeze the ethane hose. Please remember always your blotter settings, just to be sure that your experiments are with the same settings. If you then go here again to settings, there are some extra settings. Important is the TF heat power. It's the heat power which makes you this flow of the liquid nitrogen. You see the foam, what is going on. It is what the TF heat power is doing. Windows heat power is important only if you are not working with 4 degrees but a bit with higher temperatures. If you are happy with everything, you can go to prepare and you are back on the main screen. You can see that the liquid ethane value is already blue, meaning that we can start filling in the liquid ethane. As mentioned before, please always wear the protection for handling the liquid ethane. As I said before, there are 2 hoses for liquid ethane, or 2 valves, sorry. So you can open the bigger one, you can open it fully until you feel no resistance anymore. And the smaller one, you open just half of the rotation. And now you can see that the liquid ethane is coming in. and there is the foam creating, and after the foam is created there are drops slowly creating on this metal cap, and the drops will start to drip into this metal, ethane container. So it takes some time after it is filled, so we have to wait. You please don't try to make it quicker, just to be sure that you are safe. So after it is completely full, yeah, there are, as I mentioned before, there are two valves. This one is the one which is open fully. I can feel no more any resistance, and this one is the one that I opened just half of the rotation. So since it is now full, I can close it. Again, this is half of the rotation, and this I have to close completely. Please be sure to close both of them. It's our safety feature not to lose the ethane in the room. Here you have to be careful, and you just lift the metal ethane ink and you put it in here, and please always leave it like that to be sure you are not crashing into this and breaking it. You see now the ethane container is filled. How you can see it nicely is if I put the tweezers inside. You see now it's reacting already on top. The liquid nitrogen, the ethane temperature went down again while refilling the ethane, so we have to wait until it reaches our preset value. After the liquid ethane container temperature turns blue, meaning that it starts to be okay-ish, so we can continue. It's always necessary that you take care to avoid the contamination. Firstly, we have to refill the liquid nitrogen to be sure that you are not running out of it. But now you have to be careful not to contaminate your liquid ethane. That's why we will use the filter paper to protect the liquid ethane container. And we can start refilling the liquid nitrogen. Be careful, you can see there is a snow contamination creating on the beaker. So to remove it, it's always nice to take care of it, because you don't want to contaminate the container where you are putting your samples. And now you can start to refill slowly the GP. After the liquid nitrogen value is again on 100, and you are happy. Now you can see it's a bit overfilled because we can see the liquid nitrogen. We can remove the filter paper, and as I said, to avoid contamination of your liquid nitrogen, you put the lid in here, and there is the GP lid in here, so it's nice that no snow is falling into your nitrogen container and contaminating your samples. Now we can start to glow discharge our grids. All of the tools which are necessary you can find in the drawer saying GP tools. There are the squares for glow discharging, there are grid boxes, all of the tweezers and pipettes. I already prepared everything, so I put the grids into the square with the side up what I want to use, and we can go to glow discharge. Here is our glow discharger. You just raise the top, it holds, and you put the grids inside. Please always wear the gloves while doing it, not to contaminate. There is a vacuum inside and it would take them ages to pump it down. Then you can close the glow discharger and switch it on. It's important to wait until the vacuum reaches 10 to minus 1 millibar. There is even a black arrow saying that yes, it is reaching the values. Also important is time, which you can change in here. We are using at least 60 seconds of blow discharging. Why is it important to blow discharge? It's because of the reason that the grids are hydrophobic, and by blow discharging they start to be hydrophilic. It means that if you put the drop of water to the grid, which is no blow discharged, then you can see that the drop of water is not spread completely through all of the grid. If the grid is blow discharged, it's spread much more equally. So since we reached now the vacuumed value, what we wanted, we just press the start sputtering, and you can see that the blow discharges starts. There is a counter where you can see how many seconds the blow discharging is already running. So until the 60 seconds are done, you just switch off the machine, and you can hear that it's being evacuated. So far you cannot open it because there is still some lower vacuum. Now the evacuation stopped, so we can open it and carefully take our square. Please always close it again afterwards, not to let any contamination to go in. And put the square in here that we can use the grids. The blow discharging is time dependent, meaning that you should use the grids as soon as possible after blow discharging. That's why we are usually blow discharging just 5 grids to have one extra, because normal grid boxes have space for 4 grids. Then it takes some time to exchange the grid box, put it into the Falcon and everything. So we blow discharge normally 5 grids, and then while making all of this transferring, we blow discharge the next batch. Then we have to cool down the viewer and put there our Falcon. It's always nice to have it prepared, not to lose the time then when you are already freezing and realize that you have no place to put your grid in. Again, there is this bubbling, this boiling effect, so we have to wait a bit until the viewer is cold. When it's done, we can refill. You can hear even the sound of that the boiling effect is ending. Now you can see the huge bubbling, the huge boiling stopped, so meaning that it's cold. And we can put in the Falcon. You can see there is a metal weight inside. It's that it's for cryo storage, that your Falcon is not floating somewhere away. It also takes some time before this metal weight is cold, so please, as I said before, be sure you are preparing this before you start freezing your grids. Since I now touched with these tweezers the liquid nitrogen, there is the tool dryer. It's set that it stops automatically after 45 minutes, so you don't have to worry about it. And you just press on. It starts to blow the warm air in there, and it's good to leave your tools to always dry, not to contaminate anything other with the snow or with the ice. So now we can start the freezing itself. We have already prepared the program for ourselves that I have shown. So there is first rotation, second rotation, sensor, auto plunge, and the blotting time is 2 seconds with no pre or post blotting. So we can press OK. We can check that the liquid nitrogen is on 100% and the liquid ethane temperature is on -183. so it's totally fine. Now we can raise the lid and start preparing. You can see that the tweezers have the cut in here, and this black tool with what you can close the tweezers or lose them. The cut, there is the same cut on the GP, so the tweezers then go like this inside. There is only one way how to put them, so and this is it. As I said before, I'm right-handed, and since I have the first rotation, meaning that I put my tweezers like this, they will rotate while going in, so they will be like this. Then I can pipette my sample. Then I have the second rotation, which is before blotting. It's here, and then there is this blotting time, and then since there is the auto plunge function is on, it will plunge automatically the tweezers to liquid ethane. There are two possibilities how to make all of these steps. One is to touch the screen to say which step you want to do. Other one is that we have a pedal, so if you press the pedal, it goes automatically to the next step. It's much more comfortable for me personally, so I will use now the pedal. So, as mentioned before, I have the first rotation, so I will take my grid with the cut part facing up. It's important that you take the grid just on the upper ring, because otherwise you can see the gradient of the ice thickness. Also, it's important that you check that the grid is really fixed in the tweezers, not to lose it on your way. Now, as we checked everything, we can go with the tweezers inside. And as I said, now I can either press on the screen or I can press the pedal. You could see now the first rotation. It goes in, and now there is a way for right and left-handed people. As mentioned a few times already, I'm right-handed, so there is this closing device, this window, where you can pipette your sample. For left-handed people, it's from the other side. So we usually, for normal samples, we are pipetting 4 microliters of the sample. If there is another technique which is called backside blotting, where there wouldn't be the other rotation, but it would blot from backside. Or if you want to have your samples for tomography, then we are usually pipetting 3 microliters of the sample and 1 microliter of gold. So I open the window. It's always good to close it afterwards, just because the chamber is humidity and temperature controlled, so not to lose anything of that. I go as close as possible without touching the sample, the grid, sorry, because otherwise you could lose it, and I can pipette. So you see there is a drop, and if I now press the pedal, there is a rotation, and now this blotting starts. Now the sensor realizes that it's blotted, so it takes 2 seconds, and now there is the auto plunging procedure. The chamber rises automatically, and now our sample is in the liquid ethane. I already prepared the grid box, which is inside. It's quite important to pre-cool it before, because otherwise, as you have seen it before, it starts boiling and it contaminates your ethane. The cut of the grid box is visible with the red line, so I have to rotate that I can put my grid easily in. Now there is a next step where, sorry, I'm talking now and I realized one more thing. It's important not to talk too closely, otherwise the liquid ethane and nitrogen is being contaminated. As you can see that the foam is all over, so it's always better not to breathe super heavily and into your liquid nitrogen, otherwise you could see the contamination. Another step what you can do is to raise the grid a bit under the liquid ethane, you see, and now to remove the tweezers. Sorry, it moved again, so I will again prepare it to my position of interest. Now I can take out the tweezers, it's just the movement towards you. Be careful not to move with the grid really down to crash to the bottom. Now I can raise this part. I think everybody will find his way how to do it. This is mine and I find it kind of nice. And I can quickly transfer for liquid ethane from liquid ethane to liquid nitrogen. You should be as quick as possible not to contaminate your sample. Then I can locate the hole and leave the grid to fall down in there. After you are happy and you make this with all of the 4 grids, I put the tweezers to the tool dryer because they are contaminated now. I can press the pedal again. It raises this hole to the preparation position, and I can continue with up to another 3 grids. Now it's important after you are done to close the grid box before you put it into the falcon. Again, it's important to have your tools pre-cooled, so that's why I pre-cool it in the liquid nitrogen in the dewar. It again takes some time, so you have to be patient, but it's always better to wait a bit longer and to be sure that you are on the safe side than to regret that your grid is devitrified afterwards. So here it's also quite safe because it's also with liquid nitrogen vapor, so it's cold. Now I will bring the top to the position where it should be, so not to lose any grids. It's in here, and with my second hand I can close the falcon. So I just screw the screw in. After it's not possible to screw in anymore, I can check. You see that, you see that it's really not possible to move with the lid anymore, so it's safe. Both of the tools can go to the tool dryer now to avoid any further contamination. And now there is a way how to transfer the liquid or the grid box with the grid box container safely to your falcon. So there is this tool what I'm now cooling down, and if you can see the hole on the corner which is facing me, or what is facing basically me, you can screw this tool into this hole. You have to be gentle, not to press too hard, otherwise you could spill your liquid nitrogen everywhere and destroy your grid. So now you can raise it, and you see the grid box is still safe in the liquid nitrogen, so you can move it in here. Now I need another tweezers, so I can take tweezers, again pre-cool it, and after it is cooled completely, I take the grid box and transfer it under liquid nitrogen to the Falcon. After I am done, I can again transfer this metal container back, unscrew it, and I can start using it again. If you put in a new grid box, as I said before, be sure it's pre-cooled, not to contaminate your ethane completely. When you are done with your experiment, so I just ended, I use these tweezers. Always disinfect them with liquid nitrogen. It's always necessary to disinfect everything to make sure you are not ruining anybody else's experiment by contaminating his or her samples. So please always make sure you are disinfecting everything. After your experiment is finished, you have to check if somebody is freezing after you or if you are the last person. Anyways, every time you remove the liquid ethane container, you just take it and put it into this styrofoam box really carefully, not to burn yourself. And you put it underneath the exhaust where you leave the liquid ethane to evaporate. Other thing what is necessary is to remove the liquid nitrogen container, and there that you just leave to dry on the tool dryer. Then you remove the filter paper what you have used. And as mentioned before, it's important to disinfect everything with ethanol. So you disinfect this metal plate and also leave it dry in the tool dryer. And as I said, if you are the last person, you can start the bake out. If not, then you can just refill the liquid nitrogen, put the lid on, and in settings you set the TF heat power to something like 20% and leave it like this, that the next person knows that the TF heat power is set to lower. Since we are the last ones today, then we can start the bake out. If you refill it, then it takes it is called for like up to 1 hour or 2 hours, so you have to be sure. The bake out itself, it takes 2 hours plus the time for liquid nitrogen to evaporate, so it's not possible to make it quicker. So if somebody is there after you after 2 hours, be sure not to start bake out or 1 hour, because you would screw up the experiment for the next person. So then you just press bake out. Safety warning, remove the cryogen container. We have done this. So you just press OK and you can start bake out. Here you can see that in humidifier it tells me that I should drain the water. For that I can use the syringe again. So I just plug in the syringe, open the valve and remove all of the 60 milliliters of water what I have put in before. It's always double distilled water what we are putting in. So I just leave it in here. Now you can see that the message changed for open door for chamber bake out. So we open the door for chamber bake out. We can say that we have done it, and here we can press start bake out. You see that time starts after LN2 is empty, is the time when it's removing the liquid nitrogen. You have seen it was 50% still left, so it's removing the liquid nitrogen from there, and then the 2-hour timer will start. The last part is removing your falcon to the liquid nitrogen storage. There are these big tweezers. Again, you have to pre-cool it. With what you can use them to raise your falcon, to put the lid on it and screw it on. And after the falcon is closed, you can slowly move to the liquid nitrogen storage. There are these bigger gloves, what you have to use not to burn yourself, and again you have to use goggles to work in there. After you open it, you can see that there are a few positions, and every position have its name or its number and letter. So every position is unique. Every group have its position, so please respect it and write down where you are putting your sample. So then you can just take your falcon, choose the position of your interest, raise it. Please be careful, because if there are some other falcons, what can happen is that the other falcons are falling down. So don't raise it completely and quickly, just raise it slowly. Put your falcon in and leave it slowly sink. After your falcon is in, you can close the storage and you can be sure your samples are now safe.